This video will walk you through lesson 14.5, which is continuing on with our study of permutations and combinations as ways to count up the number of elements in a sample space. So just as a reminder, we learned on Wednesday that we use permutations in situation where order matters. In that case, for example, taking a group of 3 and lining them up ABC would be different than the arrangement CAB. In a combination, we are working in situations where order does not matter. So choosing 3 people ABC would be the same group as CAB. It doesn't matter who's picked first, second, or third. We are still creating a group of 3 with those same 3 people. So let's get into your notes then. So from section 14.5, we're going to start by dealing with situations where we're using combinations or permutations in situations using the word or. So what you want to do in these situations is find each individual combination, or it could be a permutation, and then you're going to add those two results together. So the word or is going to signal us that we need to add. Example number 1 says, a soccer team has 18 players. In how many ways can the coach randomly select 2 or 3 players to be co-captains for the next game? Notice the word or there, so I'm going to circle that. This would be the situation where the coach hasn't really decided if he wants to pick 2 co-captains or 3 co-captains, but we want to know the total number of ways either way. When we're selecting co-captains, the order does not matter, so this would be a combination situation. He has 18 players to choose from. The number of ways that he could pick 2 co-captains would be 18 combination 2, and that is 153 different ways. The number of ways that he could pick 3 co-captains out of the 18 players would be 18 combination 3. 18 combination 3 is 816 different ways. Now, the total for 2 or 3 co-captains would be the sum of those. 153 plus 816 is 969 different ways. Go ahead and try example number 2. Pause the video and then restart it again to check your answer when you're done. In example number 2, we have 45 members of a football team. The coach wants to select either 4, 5, or 6 players to be drug tested. Again, notice the word or there, so we'll circle that. That's going to tell us that we need to add after we calculate all of our different individual combinations. The number of ways that they could select 4 players to be drug tested would be 45 combination 4. The number of ways to select 5 players to be drug tested would be 45 combination 5. And the number of ways to select 6 players to be drug tested would be 45 combination 6. Now, the total number of ways to select 4, 5, or 6 players would be the sum of those numbers. So we add those together, and the grand total is 9,515,814 different ways. We're also going to look at some situations where we want to combine combinations and permutations using and. And in this case, we're going to find each individual combination, then multiply those results together. So and is telling us to multiply. In example 3, suppose that a basketball team has 14 players. 6 of them are guards and 8 are forwards or centers. In part A, it says, if the coach wants to pick 5 players for the starting lineup by picking names from a hat, how many possible groups of 5 starters are there? In this situation, we are assuming that the coach doesn't care what position the players are in, that he just wants to pick 5 of the 14 players to be starters for the game. So it doesn't matter if the players are picked first or second or fifth, they're all going to start. And so this would be a combination situation, and we would calculate 14 combination 5. 14 combination 5 is 2,002 different ways to pick the starters. Now, a more realistic situation would be that the coach would separate the team into 2 groups according to the position that they play. So let's suppose that he wants to pick 2 guards and he wants to also pick 3 forwards and centers. And notice we are combining using the word and here. Okay, so we'll circle that and because that's going to tell us that in the end we need to multiply our 2 individual results together. Now, if the coach is going to pick 2 guards, he's picking 2 out of the total number of guards that are available. And it says at the top that there are 6 guards on the team. So he wants to pick 2 guards from the 6 that are available. Now, the coach is also going to pick 3 that are either forwards or centers. And it says at the top that there are 8 forwards or centers on the team. So he wants to pick 3 from that group of 8. So this is 2 separate combination calculations that we're going to perform. 6 combination 2 would give us 15 ways that the coach could pick the 2 guards. 8 combination 3 would give us 56 ways that he can pick the 3 centers. And then the total for the starting lineup would be the product of those. So 15 times 56 would give us 840 different ways that he could pick his starting lineup. Notice that this is smaller than the answer that we got in part A, because here he's separating the team into 2 groups and restricting the number of players that can be picked for each position. All right, let's do example number 4. This time we have a baseball team with 15 players, and it says that 6 of the 15 are outfielders. And it doesn't state in this problem, but what's implied here by that is that the rest of the team are not outfielders, right? So let's write over here that we have 9 players that are in the other positions. And I'm sorry about my handwriting being terrible. Looks like a 2-year-old wrote that. But we're going to say that there are 9 others on the team. So just keep that in mind that when we are making our selections, we're going to have a group of 6 that are outfielders and a group of 9 that we're going to pick from. All right, so first question says, how many ways are there for the coach to choose 9 of the 15 players to play in the next game? Like our basketball example, this is assuming that the coach doesn't care what position the players play. So he could select an outfielder and tell them they have to play first base, for example. And we know that that's not going to be a likely situation, but anyway, that's what they're asking us to find. So in this case, he's using the entire group of 15 players on the team, and he is selecting 9 to play in the next game. 15 combination 9 would be 5,005 different ways. Now in part B, it says, how many ways are there to choose 3 outfielders among the 9 selected? Now this one you really have to read between the lines because he's going to select 3 outfielders, but he still has to also pick 6 other players to play, right? He has to have a total of 9 players. So it doesn't state that, but it is implied in this question. So he is going to have to pick 3 outfielders from the 6 that are on the team. Right? We know at the top it told us that there are 6 outfielders on the team. Now he still has to pick 6 other players to make a full roster of 9. And those last 6 are going to be selected from the 9 players that are considered others on the team. So he has to pick 6 others from the 9 others that are possible. Again, both combination situations because the order doesn't matter. So picking 3 outfielders from the 6 would be 6 combination 3, which is 20 different ways. Picking 6 others from the 9 others would be 9 combination 6, which is 84. And again, this is implied and because he has to choose 3 outfielders and 6 others. And so we're going to multiply those results together. 20 times 84 is 1,680. All right, to go ahead and pause the video, go ahead and try this example and then turn it back on again once you have completed it to check your answer. Okay, in example 5, we have a football team that has 25 offensive players and 20 defensive players. The coach wants to pick 11 from each group as his starting lineup for Friday night's game. And so we want to know how many ways the coach can do this. So he's going to keep them separated into the 2 groups, offense and defense, and he's going to pick 11 from each instead of just randomly picking 22 players overall from the total group of 45. So first, the coach would do 11 from the 25 offensive players. This would, of course, be 25 combination 11. And that's a really big number, so we're not going to take the time to write that out right now. But the important thing is that we know it's a combination. Secondly, he's going to pick 11 from the 20 defensive players, and that would be 20 combination 11. Now, when we go back and add those 2 individual, or not add, we're going to multiply those 2 results together. That gives us a really big answer. It's about 7.486 times 10 to the 11th power. All right, that concludes lesson 14.5. You should receive a copy of the 14.5 worksheet from the guest teacher today. Be sure that you're turning in any assignments from the week. So if you have 14.3, 14.4, any of those late ones to turn in, get those wrapped up and turn in today too, please.